Rate of change is one of those problems you would have covered in Algebra 1. We haven't really worked a whole lot with it this year. Never had, again, time to do it. As you know, we fell behind because we just didn't have as much time as students had last year to do some of this stuff. But rate of change is one of those problems you would have covered in Algebra 1, so we've pushed it off. It's not a difficult thing to do, but it does require you to sort of memorize the formula. Now, the formula is not really a big deal to memorize, in my opinion. The rate of change formula, although it's not on our reference sheet, so it is something you do need to keep in mind, kind of remember. The formula goes m, don't worry about the m, it just means slope, okay, that's not the formula part. M equals y2 minus y1 over x2 minus x1. Other ways referred to as the change in y, which sometimes they use this little triangle thing to reference that, a change in y over the change in x. So what's the difference between the y values over what's the difference between the x values? It is important, though, that we don't mix things up. You'll see what I mean when we work a problem out. So my example, use the table to calculate the rate of change. Find the rate of change between x equals 0 and x equals 2. So we need the points. We need ordered pairs for this. It gives me a clue as to where to start. X equals 0. That's the point. When x is 0, it's 0, 55 is my point, right? And x equals 2, that's going to be the point 2 and 78. So now it's just basically the formula, right? Change in y over change in x. So let's call this x1 and y1, x1 and y1, and this x2 and y2. Which would mean if you plug it in the formula, it's going to be 78 minus the 55. So this value minus this value. And then over 2 minus 0, which again is going to be this value minus this value. Now keep in mind, you can't have one of these backwards. Like for instance, don't put the denominator as 0 minus 2 rather than 2 minus 0, because then you're going to get the wrong number. So here's how you can kind of keep up. Make sure everything's in line. This should be the same point, and this should be the same point. So that's correct, right? 2 goes with 78, 0 goes with 55. You don't want them to be, is there like an undo tool? I guess not. Let me just kind of erase this gently. You don't want to have it be opposite. So let's say again, if you did 0 minus 2 instead, you'll notice that when you circle it kind of like I circled it before, 55 doesn't go with 2, right? 55 goes with 0. Those would be like crossing each other. You don't want them to do that, okay? That's an easy way to know that you did it wrong. You plugged them in wrong. Gosh darn it. So many colors, so difficult. All right, x2 minus x1. All right, so what was it? 78 minus 55, and then 2 minus 0. And that's all you got to do. I mean, you can use a calculator on these questions. These wouldn't be on a non-calculator question. So 78 minus 55 is 23, and then 2 minus 0 is 2. And 23 divided by 2 is 11.5. Right, so your answer is 11.5. So you're just evaluating. It's pretty much as simple as just plugging them in. But make sure you can plug them in right and carefully. The y's go on top and the x's go on bottom. And again, make sure that these line up properly. Doesn't matter if the 55's first and the 0's first, or if and the 78's second and the 2 second. Doesn't matter which one's first and which one's second. As long as they're lined up like that, you should be fine. Make sure they're not, lined up diagonally, because then that's going to be wrong. All right, so you could have used 55 minus 78 and then 0 minus 2. That'd be fine, because 0 and 55 still line up, and 78 and 2 still line up. Okay? And then you can do the same thing for 1 and 5. But I'm going to use, I guess we'll just show you that real quick. So x equals 1, that's the point 167. And then x equals 5, that's the point 5 and 112. Alright, so again, you're using the formula, you're going to take 112 minus 67. Remember, the y's go on top, 112 minus 67. And then the x's go on bottom, which would be 5 minus 1. And as you'll notice, I kept them lined up, right? 112 goes with 5, 67 goes with 1, so I'm good. I'm good to just go ahead and work it out. So 112 minus 67, geez, I'm trying to do this in my head. 112 minus 67, 12 and 38, 49? No, definitely not 49. Man, I don't know. I'm trying to do it in my head real quick, and it's not coming to me. Anyway, work it out, and you get an answer. Okay, it's already on your paper, whatever it was, because I had done this before. But I'm just not thinking straight right now. All right, let's move on to example number 2. Okay. A sandbag is dropped from a hot air balloon at a height of 245 meters. The bag's height from the ground in meters. H of t is modeled by this formula, okay? Negative 4.9 t squared plus 245, where t is the time in seconds. What is the average rate of change in meters per second of the height of the object between 3 and 6 seconds? So I made this question because it's basically identical to one that was on our practice test. And here's what you need to do, okay? It's already telling you basically what the same thing the first example was telling you, what the x values are, okay? It's saying between 3 and 6, or I guess t values in this case. But t is 3 and t is 6. All we need are the y values that go with it. So what we can do is plug these values into the function and find out what the y values are before we use the rate of change formula, okay, slope formula. So if you're going to plug in 3, right, plug in 3 first. Negative 4.9, then 3 squared plus 245, right? That equals, let me use my calculator. All right, go back to this, clear that. All right, so we had negative 4.9, and then use the parentheses, plug in 3 to the second power, and then plus 245. Right, we get 200.9. So let me write that down real quick. All right, now what we also need to do is, while I'm on the calculator, go ahead and plug in 6. So let's try this one more time, negative 4.9, and then we'll plug in 6, we'll do to the second power, plus 245. All right, and we get 68.6. So now we have everything that we need to go back to our slope formula. So for 3, at 3 seconds it was 200.9, right? And at 6 seconds it was at 68.6. So now you're just plugging this stuff into our slope formula. So change in y or change in x. So 68.6 minus 200.9 over 6 minus 3. Now some of you might have done this backwards. Some of you might have done the top as 200.9 to minus 68.6, and that would be fine as long as you switch the bottom pieces around as well, okay? Like I said before, make sure that that lines up as one point, right? 6 and 68.6 is a point, and this lines up as a point. If you've done that, you should be fine. It doesn't really matter the order in which you did them, okay? So work that out. Let's see, 68.6. Let's go back to our calculator. I have to erase this, which is the unfortunate thing. Back to our calculator. 68.6 minus 200.9 is negative 132.3. Let me write that down. Right, and then obviously 6 minus 3 would be 3. So our answer would be 132, I should have kept the calculator out, negative 132 divided by 3. Whatever that equals will be our answer, okay? So the trick here is it's telling you what the x values are, okay? Or the t values, whatever they're called. Plug them in, get their corresponding values, and then use that formula, okay? Just like you did in the first example, all right? So for number 1 and 2, you're doing pretty much just plugging in that formula over and over again until you tear your brains out. okay? And number 3 looks like as well. Number 4 and 5 are the ones where you have to do a little bit more work. So remember, I'll help you out with number 4, just get you started a bit. With number 4, it says between 1 and 3 seconds. So this is when x equals 1 and when x equals 3. Again, plug those in to the function, see what you get, and then use the formula. So negative 4.9, this is where you use the calculator. Plug in 1 first, see what that equals, and then also plug in 3, see what that equals. And whatever they come to, use those points. So this would be the point 1 and whatever you got, and then this would be the point 3 and whatever you got. Then you can use that slope formula, okay? So it's a little bit longer, but not necessarily harder, because the calculator does most of the work for you, okay? It's just the difference between this problem and the other problems is the other problems already had the y values, so you didn't have to already find them. You just use them. Here you actually have to find the y values first and then go about doing the same exact thing. All right, I'm going to end it there, guys. I hope it was a little bit helpful. It's something you guys should be capable of. It's very similar to Algebra 1. Okay, call me over if you need me for help. All right, bye.